Greetings and welcome to another Dev Bootstrap screencast. In this screencast, we're going to look at gas in the concept of Ethereum and transactions. We're going to look at how you can check the gas price, how you can check gas used in a transaction, how you can calculate the transaction fee based on the gas price and the gas used, and how we can use some helper methods provided by Truffle to estimate the gas for executing methods and functions in a contract and deploying new contracts. So I'm sure that as an Ethereum developer, no matter what level you're at, you would have come across gas. And it'll be one of the first things that you will have to look into. And if you check this website here, ETH Gas Station, you can see the current recommended gas prices in Gwei. And you see there's sort of three tiers. There's the trader level, or which basically means that you'll get your transaction mined as soon as possible. So these are the sort of fees that miners will go, yep, I will take that transaction, I'm going to mine it because the fee is what I am looking for, it's market rates. 30 is going to give you fast, and sort of 24-ish is going to give you a sort of standard rate. Now these values change a lot. And I've seen these go way, way up to crazy levels, you know, in the sort of 500s, and back down to sort of more reasonable levels. In fact, if you want to check the history, you can check this website, the Etherscan website /gas tracker, and you can see the gas over time and the gas guzzlers, so to speak, the biggest contracts that use the gas. Now, what I want to do in this screencast is actually check out gas in Truffle. So I'm going to move over to here and I'm going to start up a Ganache blockchain, like so. And as you well know, when you start up a Ganache local blockchain instance, it will set the gas price for you right here, as you can see here, right? And I believe that's 20 Gwei. We'll check that in a second. And so that's what we're interested in at the moment, is the gas price. And the other thing we're interested in is the fact that each account gives us 100 Ether. So first thing I'm going to demonstrate here in this screencast is what happens when you make a transaction between accounts. Okay, so for example, if I wanted to send, let's say, 1 Ether from account 0, this account here that I've got highlighted, to account 1, this account here. If I wanted to send one of these 100 Ethers to this account, you would expect, naively let's say, that the balance here would change to 99 and the balance here would change to 101. Well, in actual fact, that's not going to be the case. The second account will definitely be 101, but the first account is going to be slightly more than 1 Ether deducted. We'll have slightly more than 1 Ether deducted. And this, of course, is due to gas. Let me show you over here in this terminal window. What I'm going to do is I'm going to open up Truffle console, like so. So Truffle console. This Truffle console will connect to this Ganache here, as you can see. And if we just do a sanity check, I can check the accounts, and we can see we've got these accounts loaded. So what I'm going to do, as I mentioned, is I'm going to send 1 Ether from this account to this account. So I'm going to move this over a little bit so that we can see both windows, and I'm going to submit a transaction. And I'm going to use the Web3 framework. So Web3 ETH send transaction, and that's the function we're going to call, and you pass in an object which is going to have the from, to, and values. So the from is going to be the accounts 0. So accounts 0, of course, is this account, is the first account in our array of accounts. 2 is accounts 1, which is the second account, so it's there. And the value, as I mentioned, is going to be 1 Ether. And I'm going to write this out using a notation that just basically says that I'm going to multiply 1 by 1 times 10 to the power 18. So 1e18, like so. this basically means that I'm sending 1 ether because the value field here is expressed in Wei, and 1 ether is 1 times 10 to the 18 Wei. So let's execute that. Let's hit the enter button, and we get a transaction returned. And as you can see, we get back some interesting information, but what we're interested in specifically in this screencast is the gas used, which is 21,000, right? 21,000 gas. You can see over here in the Ganache output, it also gives us that information. Okay, gas used is 21,000. Now let's check the balance of account 2, which I said would be 101. So web3 ETH get balance. Accounts 1, so this is the lucky account holder, and yep, they've got 101 ether, and we can divide that by 1e18. We can divide this by 1e18, and we get 101. Okay, that's basically, I just converted Wei into Ethereum if you wanted to do that. That's one way of doing it. And so we can see that the total there is 101, which is kind of, you know, as expected in a naive situation. That's what you'd expect. But how about the balance of account 0? What's that going to be? Is it going to be 99? No, it's 98.9. Oh, sorry, 98.9995 ether, which is expressed here as in Wei. So what's going on? Well, it's the gas, right? It's the gas that is applied to the transaction, and then there's a transaction fee, and that transaction fee goes to the miner. So how can we calculate that using gas, right? So the first thing is we need to know what the gas price is, which is here. In our local Ganache, that's the gas price. Now, if you're on a testnet or the main net, you can use Web3 to get your gas price. So let's type out here, I'm going to clear the screen here, I'm going to say gas price. So gas price is equal to Web3 ETH, oops, Web3 ETH, get gas, oops, sorry, get gas price. And I need to put a weight here, actually, because it's going to fetch the gas price, right? Now we can take a look at that, and there you go. It's the same value as we have here, and if I divide that by 1e9, you can see it's 20 Gwei. So it's 20 Gwei because this number is in Wei, and I divide this by the number of Wei in 1 Gwei to get Gwei. So 20 Gwei. Cool. So 20 Gwei is the cost of the gas. So how much gas was used in the transaction? Well, when we transfer ether between accounts, it's always going to be 21,000 gas. So that can be our gas used, right? So we're going to say just gas used is that. So now we got our gas price, and we got our gas used. So basically, the function to calculate the gas fee, or the transaction fee, I should say, is basically the gas price times the gas used. And because we are dealing with very large numbers, I highly recommend, no matter what the number is, to convert to a big number. And fortunately, we can do that using Web3. So I'm going to say gas price BN is equal to Web3 utils to BN, gas price, right? And that gives us our gas price BN. Gas used BN is equal to Web3 utils to BN, and then gas used, like so. By the way, this notation here, you can sometimes read it, sometimes you can't, depending on how big the number is actually. But if you want to read it, you can just tag on 2 strings. So for example, gas price BN to string will give you the number back as a string. So now what we want to do is multiply these two numbers together. So I'm going to say TX fee is equal to gas price BN multiplied, and I'm going to use a function that's provided within the big number API. In this case, I'm going to use the function MUL, which is for multiply. This is the beauty of big number libraries, that allows you to perform these mathematical operations in a safe way, without overflow or any issues with that. And we're going to we're going to multiply this by gas used BN. Okay, so gas price multiplied by gas used is our transaction fee, and that gives us another big number. And if we output the value to string like so, you can see it's this number here, which if I divide that by 1 to the power 9, you can see it's 420,000 gwei. 420,000 gwei. That's the number in wei, and this is just this is converted to gwei. So 420,000 gwei. So that is the cost of our transaction. That was the transaction fee applied to send that 1 ether from those two accounts. So let's take a look again at the balance of account 1, or the first account, sorry. So the balance of account 1, I'm sorry, the balance of account 0 is Web3 ETH get balance accounts 0, and you can see here that it is actually 1 ether, so 1 ether has been taken off, and also this amount of gwei has been taken off as well. And let's just check that out. So let's start with what the initial balance was. So initial balance would have been 1 ether, right? So the initial balance is 1E18. That's the I'm sorry, not 1E18. It's 100 ether. So we're going to start with 100 ether. That's our initial balance, and we want to take off 1 ether, and we want to take off the gas. So we're going to say, let's say subtraction amount is equal to the amount of the transaction that was taken off, which is 1 ether, so 1E18, and we want to also add to that subtraction amount the amount of the transaction fee. So I'm going to convert this to a big number, Web3 utils to BN sub amount. Okay, and then I'm going to add to that the amount of the transaction fee. So the sub amount BN, add TX fee, which is already a big number, and this is the total to deduct. Okay, and then finally, this is just to sort of show what we want, what we should end up with. So it's the initial balance, which is 100 ether. So it's the initial balance subtract the total deduct, should give us yes, of course. Initial balance needs to be converted to a big number. So we just say big number Web3 utils to BN, initial balance like that, and then finally initial balance BN sub the total deduct, and then let's wrap that in parenthesis and output the value as a string, and okay, and then this number here should be the same as our balance, and it is. Okay, so basically what I did there was I calculated the amount of the transaction fee, and then I applied that to the initial balance of the account, which was 100 ether, and then I subtracted 1 ether and plus the transaction fee, and you can see the numbers are the same. So that's a quick overview of gas when applied to sending ether between accounts. But what about between an account and a contract? Well, I just so happen to have a smart contract at the ready, as always. Here's a simple store contract. This is available in GitHub, as always. It's a very simple contract. It basically sets a value in the constructor, and it allows you to set the value via a method, and it also allows you to get the value also via a different function or method there. And the migration, if we take a look at that quickly here, it sets the value on the deployment to hello world. And we also have a few tests as well for this contract. So I'm going to come back to the terminal here, and I'm already opened up Truffle console, and I'm going to migrate the contract. So migrate, reset, like so. It's going to deploy the contract. If we check the networks, we can see the contract addresses. And what I'm going to do is I'm going to just interact with the contract here in the terminal and show you how we can utilize gas in this scenario. So first thing is I'm going to create a variable called SS, simple store, and I'm going to wait simple store deployed like so. And that will give me an instance of the contract. So if I say address, I can see that the address is the deployed address of the simple store. And if you just do ss dot and hit tab, you'll get the various methods that are available. And you can see the methods that have been defined in the contract: get value and set value. So if we take a look at get value, we should see the hello world, of course. Now, get value is a read operation on the contract and therefore does not cost any gas. However, a set value operation will cost gas. Now, I'm just going to open up my accounts list and show you here the accounts. And I'm also going to show you the balance of the first account. So using get balance here. Sorry, Web3 ETH get balance. Accounts 0. All right. And it's slightly less than 100 ether. And by the way, I've reset the balances on everything, so since the previous example. So why is the balance less than 100 ether? Because if we scroll up again to the top of this output here with Ganache, you can see everything starts with 100 ether. So why is this not 100 ether? Now, if we check the other accounts, say account 1, account 2, and so on, these are all 100 ether still. The reason is because when we ran the migration, account 0 is used to perform the migration, and migrating contracts is not free, right? It costs gas and therefore ether. So that's why account 0 doesn't have 100 ether anymore. So in order to sort of perform these tests, I want to actually use account 1 when we set the value, because I want to see, well, what happens to the accounts balance when I call set and get value. So let's try that right now. First of all, I'm going to clear this screen here, and I'm going to call get value on the contract. But I'm going to say that I want to do this using account 1, like that. When I do that, and run that transaction, we get hello world. And as I mentioned, if I go back to the get balances, that does not cost anything. So you can see the balance of account 1, which we used in this transaction, is still 100 ether. How about if we set the value? So ss set value, okay, and in this case we need to pass in a new value, so I'll just say a new value. And then I want to send this from account 1. And let's see what happens. So in this case, we actually get a transaction object back and with the receipt. And we can see our familiar gas used entry there. And actually, if we scroll down into our Ganache, we can see here that the gas used shows up there as well. And of course, if we check the balance now of account 1, it's no longer 100 Ether. It's slightly less. And so the same approach can be used as we showed before in the previous example of calculating that gas, right? So it's the gas price multiplied by the gas used is going to give you the fee. And so that's exactly what was reduced by or taken off this account to perform this transaction, was the gas price multiplied by the gas used. And just for your information, to recap, the gas price comes from, can be displayed here using Web3 gas price, and you can see here it's that amount there, which is, if we divide it by 1 to the power 9, it's 20 Gwei, and that's set in Ganache, right, our local blockchain. Obviously on testnet like Ropsten or Rinkeby or on mainnet, gas is basically fluctuating, especially on mainnet, and you can check the gas price in the same way using this function, or on ETHGAS station, as I mentioned earlier. So that is how gas is applied when we interact with our contracts. But one interesting thing that you can use with Truffle and Truffle contracts is you can estimate the gas price. And you can do this by using estimate gas. And this is done as follows. So for example, if I have again our contract, simple store, and I want to set the value, I can actually put a dot on the end of the set value function there, and I can see some more functions that are applied to that function, if you like. And one of them is estimate gas. And so if we type estimate gas here, we can use that function to estimate the gas. And the way this works is it needs to take the parameters that you will be submitting into the function call as you would normally. So in this case, set value takes a string. So I'm going to put in a new value like so. And I'm going to execute that. And then we see that the estimated gas, this is the estimated gas, is 26,391. And actually, if you look here over here in Ganache, it did actually call a estimate gas instruction for the blockchain there, which gave us that value. Now, you can see that it's different to what was actually used in the transaction. So it is an estimate, but it's quite a useful thing to have if you want to be careful of your gas usage. Now, another thing that you can estimate the gas for is contract deployments. And the way you do that is you can use the simple store or the contract class, if you like, and you say new, and then you can say here on new, estimate gas. And again, I've just put this here to show you. It says got 0 and expected 1. That's because new calls the constructor, and if we recap over here with our contract, the constructor takes a string, which is the value. So it's like an initial value, which we can see run here in the migrations as well. So if we want to estimate this, we need to pass in the value that we would pass in, say, for our deployment, like so. And then we get our estimate of gas required to deploy this contract, which is as shown here. So that's a quick overview of interacting with contracts and looking at the gas that is used and the subsequent transaction fees that are applied when interacting with contracts. Now, Final point I want to go through in this video is how to use this in your tests. Now, one of the things that I've used in testing smart contracts is to confirm or assert the balance of an account after a transaction has been applied. So, for example, maybe there is a commission, maybe there is some reward paid to the contract owner, all kinds of different things, right? And you want to basically make sure that your logic is correct and that the accounts receive the expected amount of ether. But you also want to take into account gas. All right, you want to take into account the gas and the transaction fee. So let's take a look at a test now. So if we go over here, we can see in our simple store project that we have a simple test. It just tests the get and the set value function, but it doesn't take into account anything related to gas. Let's run this test to make sure that it's all working. And we're going to add a new test to this, which is going to basically confirm that the set value transaction costs gas. Now, this isn't something you would normally test in your own projects. It's just an example, but I want to show this just so that you get an idea of how to take into account gas when you're writing your own tests, as I mentioned earlier. So it should cost a small amount of ether or whey, whatever, to perform this transaction. And we're going to make this an async, and we're going to run the test in here. And I'm going to just say console log in gas test. And the reason why I'm doing that is because I put this only switch here, and this is a little helper method that means that when you run test, so I'll just clear this out here, it's only going to run that test, and we're in the gas test, right? So let's continue. So what we want to do is get the gas price. So I'm going to basically run through pretty much what we've done already in the terminal, but this is going to be written as a test. So we're going to get the gas price of our network. So this is going to be await web3 ETH get gas price, like so. That's our gas price. We're going to get the balance before. This is the balance of our account before the transaction. So get balance, and then it's the accounts, and we're going to say accounts 1. In this case, we're going to get, then we're going to perform the transaction, actually. So await instance set value. So we're going to call set value, and we're going to say something new, and we want to send this from account 1, because that's the account's balance that we're testing in this case. Then we will what we want is to convert our gas price that we received earlier into a big number, and then we want to get the gas used from the transaction receipt. So remember, this will return a receipt, and we can get the gas used. So gas price big number is equal to web3 utils 2bn gas price, and gas used bn is equal to web3 utils 2bn, and it's going to be tx.receipt.gas used. Okay, that's where our gas used is. Now we can calculate the transaction fee. So I'll call this transaction fee, and it's going to be gas price times gas used. And since we're using big number, we can use the multiply function. So gas price mul gas used big number. All right, so we got the transaction fee. Now we can get the balance after. So we had the balance before, now let's get the balance after. So let's just copy and paste this and rename this after, like so. Cool. And now we need to convert our balances to a big number. So I'm going to grab that and call this, and I'm going to just cheat a little bit and just use our big number function like that. And I'm going to get balance before and balance after. And I'm going to pass in the balances before and after just to convert them to big numbers. So we got the big number there. Now what we need is the difference. So the difference in balance before and the difference in balance before and after, right? So we'll create a new variable called diff, which will be the balance before big number, and we'll use the subtract or the sub method on big number, and the balance after bn, of course, and that will be it. And now we've got basically our transaction fee, and we got our difference. So the difference in the balance before and after the transaction went through using account 1 should be the same as the transaction fee. So we can write expect diff dot equal the transaction fee like that to be true. Okay, so just recap. Let's get rid of this console log here. We grab the gas price for the network. We grab the balance before of account 1. We perform the transaction using account 1. We convert gas price and the gas used into big numbers. And then we calculate the transaction fee by just simply multiplying gas price and gas used. Then we grab our balance after, and then we convert the balances before and after to big numbers so that we can then use the sub function to calculate the difference in the balance. And then we compare the difference with the transaction fee, and we're expecting that to be the same. And this test proves that we are using gas. We're using up some gas, and there's some cost to this transaction. So let's move over to the console and rerun the test. And we get an error. Gas price mul is not a function. That's because I am not using the big number. So it should be gas price bn. Let's try it again. Run the test again. And there we go. So you can see here that it should cost a small amount of whey. And this test passed, which means that the calculated difference in balances matched the transaction fee. So this is a useful way of removing the transaction fee that's as part of the transaction when running tests on the blockchain, so that you can eliminate that when calculating, say, the expected balance of an account following a transaction. As I mentioned, typical scenarios might be when you reward an account owner for adding certain liquidity to a liquidity pool, or you're giving some prizes away, and obviously these incur transaction fees in some scenarios, and so you want to make sure that you take those off to make sure that your tests are clearly identifying that the amount of whey transferred between accounts matches your expectations. So with that actually concludes my screencast for today. I hope you enjoyed it. And as always, you can check out our repositories on Dev Bootstrap. Go to github.com/devbootstrap. We've got all our repositories there for our videos, and also check us out on devbootstrap.com, and of course on our YouTube channel. And if you like this, please do not forget to hit the like button and subscribe. Please share this with anyone. Really helps if I can get subscribers. Really appreciate your support, and I look forward to making the next screencast very soon. Thank you very much, guys, and talk to you again soon. Have a good week. Bye-bye.